Hello, everyone. Today we're going to be writing ratios and solving proportions. If you guys could just pause your video and try the first example, you guys can cross off example number 2, but try the first example and pause your video now. All right, you should have gotten final answer of B equals 1 as your final answer. So check with your teacher. If you didn't get B equals 1, then you can go ahead and ask now. But getting into some of the main parts for today, first things first, we got a few vocab terms. If you need to pause your video to copy these down, you can do so now. But a ratio is probably the first keyword that we have to chat about. And this is when two numbers or categories are compared using a fraction. So when we have, for example, I wrote down we have x over 7 or t minus 4 over 5, we're basically comparing the numerator to the denominator. Now, a proportion is similar to a ratio, except for this is when you take two ratios, so two fractions, and they're compared in an equation. And we do that with an equal sign. So eventually these are going to be problems that we're going to learn how to actually go about solving. But first, let's investigate a little bit more about what ratios actually do. So we can do these with just random numbers, or we can do them in a problem kind of like this one, where it says, for example, it says a person makes 6 long distance calls and 15 local calls in 1 month. Number 1 says then find the ratio of long distance calls to local calls. So when we say find the ratio, it just means we're going to compare those two categories using a fraction symbol. We're going to do our long distance calls on top, and we're going to do our local calls on the denominator. So let's see what it actually is going to be. In this problem, it says there's 6 long distance calls, and it says there's 15 local calls in 1 month. So its ratio would be 6 to 15. Now, the simple fact that today we are going to be working with ratios or fractions. So if you'll look right below this, it says always remember to reduce or simplify, whichever floats your boat. But we always want to make sure we reduce our final fractions. So yeah, this means for every 6 long distance calls, there's 15 local calls. But if we reduce this, that's going to end up being 2 over 5. So for every 2 long distance calls, that means 5 local calls are going to be made. And there's our ratio. Number 2 says find the ratio of long distance calls to all of the calls. So if we find all of our calls, it might help to know how many total calls were made. Well, if I take 6 long distance plus the 15 local, there's a total of 21 calls that were made in this. So if my job is to find the ratio of long distance calls to the ratio of all the calls that were made, well, there's, in this case, 6 long distance calls, and we found out that there's 21 local, or not local calls, all calls that were made. So again, 6 over 21, we want to check to see if this reduces. You can do this on your fraction or on your calculator. If I go to my handy dandy trusty calculator, we're going to actually type in alpha y equals number 1 fraction. I'm going to type in 6 over 21. And now on mine does this a little bit differently. But if you guys did this in your calculator, you would have gotten 2 over 7. So that is going to be what this reduces to. For every 2 long distance calls, there are 7 total calls that are made. Now, most of the time, we don't just stick with working with just the ratios. Then what we're going to do, this leads us into kind of the ultimate goal for today, which is solving proportions. And that is what happens when we have equations where there's fractions on both sides. Now, some students kind of look at this, and especially if fractions aren't necessarily your friend, the nice part is that we have a really nice method that we can use that solves these types of problems for us. And the method itself is called cross multiplying. Anytime we're going to be solving proportions where fractions are involved in both places, we're going to go through and we're going to go ahead and use cross multiplying to solve for our variable. So how cross multiplying works, it involves when we have our equal sign, we want to start by looking at the problem, seeing, well, are we even working with a proportion? And here we are, because we have a fraction equal to a fraction. So when we look through this, the process of cross multiplying basically means we take the numerator of one side and we're going to be multiplying it to the denominator of the other side. So in this case, when we do this, the equal sign is going to stay. When I do that multiplication, y times 5 or 5y, that multiplying is going to go on one side. Now, the other side that we're going to work with, we're going to take the other denominator and multiply it to the other numerator. So 3 times 10 is going to be what goes on the right side. Now, you could have done those on different sides. It doesn't matter what side of the equation you put those on. But the awesome part about cross multiplying is if we simplify the right side, 3 times 10 we can say is 30. This becomes a problem that's a whole lot easier to solve. In order to get y by itself right now, we are multiplying by 5. So to get y by itself, we are going to divide both sides by 5. And we're going to get our final answer of y equals 6. Now, just like all equations like this, if we take 6 and plug this back in, 6 over 10 actually does equal 3 over 5. So y definitely equals 6. Now, that process of what we just did, we're going to do that again, even if there's more complicated things that are happening. Like on number 4, our equal sign is still going to come down, and we're still going to go ahead and we're going to cross multiply. But sorry about that, guys. We're back. So if I'm going to go about this process of cross multiplying, we have to start by picking a number on the left side. I usually start with the numerator. You can start with the denominator. Both are fantastic. But the key is I'm going to multiply it by the number that's in the opposite spot on the other side. So not the numerator on the other side, but the denominator. And we are going to be cross multiplying. So I'm going to multiply the numbers that are in those locations. Now we're going to do the same thing on the other side. I'm going to take 30 and we're going to multiply it by whatever's on the other side. But here, since we have multiple things, we have to remember that we're going to put these in parentheses. Because I have to remember to take 30 and multiply it to anything that's on this side. So hopefully you can kind of start to see what's happening. But let's start with simplify just a little bit. Oops, sorry. If I take 10 times 24, I know that we can get 240 for that. So if there's anything to simplify, I usually will. But this problem now is very similar to a problem we would have solved last unit. If we're going to go about continuing to solve, we can't have the parentheses. So first step is if distributing is there, we always want to distribute. So bring down everything else. If I take 30 times x, we're going to get 30x. 30 times 3 is going to end up being 90. And now continuing to solve, we want to get x alone. We right now are multiplying by 30 and adding 90. So we start by undoing the subtraction. If I take 240 minus 90, that's going to leave me with 150. And then our last step to solve for x, since it's being multiplied by 30, we're going to divide by 30 on both sides. And that's going to leave us with our final answer for x. X is going to equal 5. Now, example 5 on this, guys, you can actually cross this off. We're not going to do this example today, but that is the process of cross multiplying. So on this next page, if you guys want to pause your video now, I'm going to have you, if you want to try these 2 you try nows and see how they go, you can do so now. So pause your video and give them a try. All right, answers are up. For question number 1 here on this you try now, you should have got v equals -1. And for number 2, you should have got x equals 6. So if you did not get those, feel free to pause your video and call the teacher over. They can check it and kind of see what happened. But we are going to move on down below, and we're going to start with just a few word problems. because ratios and proportions actually are really helpful in a lot of different real life scenarios. So for example, 6, all of these, it says write and solve the following equations. So number 6 says 2 triangles are being compared. In order to be considered similar, they have to have the same ratios for side lengths. Determine if the triangles are similar. So similar triangles, they're not going to be the same. They're not going to have the same side lengths every single time. But if you are going to classify something as similar, it just means that their side lengths have the same ratio. Now, they initially might not. Like if we compare sides in this triangle, if I look at my side over here, usually we can kind of match it up and go by side lengths, things that are in the same location. So from my big to my small triangle, these sides right here are in kind of the same location. So let's check. We're going to compare those 2 side lengths as a ratio. And we're going to do this with all 3 of the sides. If I look at my next one, BC here, this one has a side length of 16. And the one in the location on the other triangle is going to be 8. And then the last side, let's see here, we have this one is going to be a side length of 18. And then in my smaller triangle, that one is going to be a side length of 9. Now, all of these right now, they don't look like they have the same ratio, but we have to remember, we have to remember to simplify. If I simplify all these, 12 divided by 6 is 2. 16 divided by 8 is 2. 18 divided by 9 is 2. Since all of the ratios here have the same length, we are going to say yes, the triangles are similar. Okay. So ratios, we don't always have to use them as an equation per se, but we are going to set that up for actually example number 7. Here it says, since we're solving this word problem, it says to feed your plants, you need to mix 3 tablespoons of plant food with 16 ounces of water. So I'm going to stop there for just a moment because here it's giving me a comparison. I'm comparing for every 3 tablespoons of plant food, we're combining that with 16 ounces of water. So when we are going to write our first ratio, a ratio is just a comparison of 2 different categories. Those right there are going to be our categories. There's 3 tablespoons of plant food, which we're combining with 16 ounces of water. Now, that in itself is great. I know that for every 16 ounces of water, it needs 3 tablespoons. But if you read the rest of the sentence here, it says, if it takes 80 ounces of water to feed all your plants, how many tablespoons of plant food are needed? So what we can do is that side of our equation here kind of sets up our right side. If you're going to choose to do tablespoons over ounces, that means the other side of the equation has to actually match. And we're going to fill in what we know. It says if it takes 80 ounces of water, well, we have my ounces of water on the bottom, so I'm going to fill in 80. And it says how many tablespoons of plant food are needed. So I don't know how many tablespoons, but that just tells me that that's my unknown. That's where my variable is going to go. And now we can cross multiply and solve. If we have right now, technically we have 3 over 16 equals x over 80. We're going to start now by cross multiplying. I'm going to take 3 times 80. That's going to go on one side of my equal sign. X times 16 is going to go on the other side. And now we can go ahead and solve. 3 times 80 is going to be 240. And then solving for x, we just want to get x alone. So I'm going to divide this 16 over to the other side. And we're going to get x to be 15. So final answer, we want to write out what our actual answer is. It's going to need 15 tablespoons of plant food. All right. So last example here, it says an architect creates a scale model of a school. The actual school is 50 feet high. The scale of the model to the actual school is 1 foot to 75 feet. So we need to start by going through here and find the things that we're comparing. So here, the place where it tells me, it says the scale of the model, the distances that we're comparing is 1 foot to every 75 feet in real life. So when we set this up, we know it's going to be 1 foot to every 75 feet, but it might help to keep in mind that it's going from the model to the real life. So, because they're both using the same, units. So it might help to kind of keep in mind what our setup is. So if it's for every 1 foot in the scale model, for every 75 feet in real life, here it's asking us to estimate the height of the model. So that just tells me I don't know what the height of my model is, but it does tell me here that the actual school height is 50 feet. So now we can go through and solve. 1 over 75 is equal to x over 50. And we're going to start by cross multiplying. I'm going to take 1 times 50. That's going to go on one side. X times 75, 75x is going to go on the other side. And now we can simplify and solve. 1 times 50 is going to be 50. And solving for x, last step, we have to go ahead and divide by 75. Now, not the nicest number, but that's okay. It's going to end up being about 0.66 repeating, or 0.67. And all this means, if we look back here, we just found the actual height of the model. The height of the model is 0.66 feet. Or 0.67 technically. All right, guys, so if you want to pause your video and try this last you try now, you can give it a shot now. All right, final answer is up. You should have got 156 miles as your answer for this. If you did not, then now's the time to call your teacher over and check it. If not, though, you guys can move on and you can start working on the homework for today, 3.7.